Good morning, Year 10s. Thanks for coming, guys. Got a load of people in the chat already. Got 9 people waiting. Doing well. Oh, we've got low internet. Oh, that's weird. Thanks for coming, guys. Got a load of people in the chat already. Oh, I've got low internet. Wonder why. Give me 1 sec. That's strange. Oh no. Low internet. Oh no. If I move over a little bit, maybe don't know whether or not it's my laptop or what. It says connection is good. I don't know why connection is unstable. Move closer to your router. No. Najma! Hello, how am I feeling today? I'm good, thanks. Apart from my internet being poor. I don't know why. I probably should have turned my computer off and done a restart. Oh no, oh no, oh no. Cables coming out all over the place. Oh no. Right, let's crack on, folks. I don't know what my internet's going to do. It might do, I'm going to switch to my clip cam. I'm really worried now. I always worry whenever my internet says it's poor connections. Okay, so I can switch this down. Let's see how we get on today. Okay. Oh, it's the stare at my forehead. What I ought to try and do is lower my webcam at some point. That would be a good idea. I don't know, something else. Hello, slideshow. Can I just quickly ask, can someone give me a bit of feedback on the feed? Is it okay? I feel like there's going to be an issue here if my internet's being iffy like this. I can't really do anything. I'll look at my router. See if I'll find my router. Yeah, it's not worth even trying to fill it. I don't know. It says poor internet. Is it okay? Guys, give me a bit of feedback. It's all right now, not as laggy as a few seconds ago. Okay. Yeah, how frustrating. I don't know whether or not me moving close. I'm trying to just shuffle down the table a little. It means I'll have to turn my camera. At least I can get a little bit closer. I don't know whether or not it's going to make any difference. It sometimes gets stuck in the middle. Yeah, I'm very aware of that. Does that make any difference? I don't know. It's not going to make any difference, is it? Connection is unstable. Yeah, don't like that. Guys, I'm just going to restart my computer. I'm going to do a hard reset. I'll leave the thing running though. And so my laptop will just reboot back into where it is at that point. I apologize for this, folks. Restart. Dick! Hello, I'm back. I'm back. With no internet sign on. Yeah. I knew that was going to be an issue. It was better to do that, guys. I'm sorry for the 4 minutes of just terrible time. How have your exams been going so far? Yeah, they've gone okay, actually. The year 11s have done really well. My year 12s and 13s have done well. I'm really pleased with them. They've worked really hard. Really, really hard as well. Like, I love them to pieces. They're awesome. Right, let's crack on, guys. Let's share screen and crack on with today's lesson. Okay, much better. Yeah, I thought it was worthwhile doing, I think. Otherwise, it just would have been a poor lesson all the way through. Right, 4 learning objectives today, guys. So today's lesson is acid-base lesson 9. This is salt preps. There's going to be one more lesson because I highly doubt that we're going to get to my solubility rules by the end of this lesson. So what I will do is I'll probably do a lesson 10 as a summary. We'll do some exam style questions as well, because that's all just relatively straightforward. It's a bit of knowledge that we have to know, but application to question is important. So I will cover that one in a separate lesson. So let's crack on. So this is called salt preparations. And what I first of all always tend to find is that some people don't really understand what is meant by the term salt preps. So what I'm just going to add here is this is making salts. This is making salts. Now, we recognize this from the equations that we picked up earlier in the series. So we know that if we have an acid and a base, acid plus base gives us salt. Salt plus question mark, depending on what we're doing. And I'll talk about that in various scenarios. If we decided to do our base as a metal, if I shouldn't really do this, I should put the base up here like this. And then I could do all the series. So I could do the metal one. If I do acid plus metal, then I get salt and hydrogen. Yeah, just a reminder of this. If I did acid plus metal oxide, and there's one particular oxide they do love you to know, that's going to make salt and water, and that's copper oxide, by the way. That's going to make salt and water. Yeah, and if we do acid plus metal hydroxide, it's the same, metal hydroxide. These rules are so important, some of the most important rules in the whole of chemistry. Yeah, this is salt and water as well. These are often lumped together. Yeah, and then if you notice that all I'm doing is changing my base. Yeah, and then acid plus metal carbonate. Yeah, plus a metal carbonate, and I will get salt water and CO2. Salt water and carbon dioxide. Yeah, so it's just nice to just remind ourselves of this. Can I just say that these 4 things are so important all the way through, including GCSE. By the way, I've suddenly realized my chat's not up. So I'm just going to go to my YouTube channel. I apologize for this. YouTube, I'll go onto my live stream because I restarted. I tried then to open up all my windows and it didn't work at all. So let's go to my channel. And then go to this one, my live one, and then I can pause the video super quick. I tried then to open up all my windows. Pause. Here we go. Oh, Najma, you are so lovely. Pop out chat. You're so sweet. Thank you so much. It's so nice for you to say that. There we go. I actually don't need that up. I just need the chat window. There we go. Chat window's there now. There we go. Cool. Aww. Okay, so it's really lovely. These equations are so important. They will follow you all the way through GCSE and into A-level. Yeah, they're so important because they just get repeatedly reinforced, and they do link a whole load of other things to this. So it's something to bear in mind. So what we realize here is in every single one of these reactions, we are producing a salt. Now, there are two types of salts. There are soluble salts and there are insoluble salts. So we can make that note. So there are 2 salt types. 2 salt types. There is, number 1, soluble salts. Soluble salts. So, and this is state symbol aqueous, and insoluble salts. Insoluble salts. State symbol S, solid. So when you do a chemical reaction, you form a salt. Some of the salts dissolve in the water and you form a solution, which is see-through. You can see through it. Whereas other salts that are produced will form a solid, which means the solution then becomes opaque. You can't see through it. It becomes cloudy. Can I just point out, I hate the term cloudy. It should be precipitate. But cloudy is the right word. It is a good word. And we do see this in the chemical test for carbon dioxide all the time. But anyway, let's continue. So what we need to do is we need to focus on the two different methods because they are different. So let's do the easy one first. So just to let you know, the insoluble salts is an easy prep. This one's easy. Yeah, this one is always the one you hope to get in your exam. Please, please, please. We always want this one. Yeah. Yeah, this is the easy one. And then the soluble salts is more tricky. This I would class as a medium salt prep. It's a bit more challenging because it has some idiosyncrasies that the other one didn't have. So, and we'll look at these all the way through this. So first of all, by the way, I've got some exam style questions that we'll look at the end of the lesson to see, and I've got an exam style question for both the soluble and an insoluble. So it'll be good to have a look at those. But let's now look at the insoluble salt prep. So we are making an insoluble salt. So first question that students always ask me, Mr. Duncan, I don't know whether the salt is soluble or not. And I'm like, I get it. Don't panic. The first thing I need to point out is in lesson 10, we will cover the solubility rules. Yeah, and we'll be able to figure out when a salt is going to be insoluble. Yeah, so we will cover that one. That's the first one. But actually, there's a second point to this. So not only can you be an awesome chemist and go, it's okay, I know my salt rules, my solubility rules. But you can also realize that the question itself tells you. Yeah, so in this question, note the state symbol. We've got a solid, which means we're forming an insoluble salt here. Let's go to the next one. Oh, that's irritating because the next one, filtered out, that's an insoluble salt one. This one's a soluble one, ammonium phosphate. And it hasn't actually told you, but this is part D, and I think it probably did earlier in the question when it gave you the equation. So don't worry, it's not the end of the world. It is tricky, but as I said, you get used to them after a while. You do. So we're going to make an insoluble salt. So the question is, how do we do that? And yes, guys, I'm really sorry. It's another story. Chemistry is full of stories, and you just have to learn some of them. But if you understand the process and what each bit's doing, then it becomes a lot easier. Yeah, I always say to students, you should never try and remember anything. You should be learning how to build something. Yeah, so we're going to make an insoluble salt, and I'm going to tell you that this is 5 marks in an exam. 5 marks. Just to show you, and there it is. 5 marks. Yep, so 5 marks in the exam, and here's the question. They simply say, describe how you could use solutions of lead 2 nitrate and sodium bromide to obtain a pure, dry sample of lead 2 bromide. So, and it says 5 marks. So it's a very clear question. It's 5 marks. They just say, how do you do, what are the 5 bullet points for making an insoluble salt? Okay, so let's walk through it. And let's do this not only just in a series of bullet points, but in reality, we need a series of pictures. Pictures are far better. So step number 1, step 1. So we are going to mix solutions A and B together. And I kid you not, that is a mark, guys. There is a mark for saying mix them together. I kid you not. Now, when you mix these together, you're also going to stir it. Yeah. So I can now add in red. This is actually a separate question outside of the method, but I like to include it in the method because it means that I hit all those bullet points. So mix the solutions together. Bullet point number 2, stir mixture. Stir mixture, I'm underlining stir mixture to ensure all react. Yeah, and I've just put all react. I could have put all chemicals react, all substances react, or the reaction comes to completion. How do you know when something's finished? Make sure you stir it really, really well. And I could actually show you a video of this as well, which is when you form an insoluble salt, you tend to form this cloud, this rather cool looking cloud. I can actually show you an image of that probably with relative ease. Let me show you one. So let's do lead iodide precipitate images. See, look at that. And I told you it would do it. Yeah, look at that. That's a really pretty picture, though, isn't it? So that's an insoluble salt because it's become cloudy. And you can clearly see that you need to stir this. Yeah, otherwise the solid will just sink to the bottom. Yeah, this needs stirring. Yeah, so you stir it to ensure that everything reacts. Another common question at this point, which I will also add in a different color. How do you know when the reaction is finished? No further precipitate will form. You won't get any extra. You'll be stirring it, it'll just remain the same. Yeah, but you can't just say it remains the same. You have to say during stirring, you will see no further precipitate happen. Yeah, no more precipitate will appear. It's another common thing. You know the reaction has finished. You know the reaction has finished due to no more precipitate. The word precipitate means solid, by the way. No more solid forms. Yeah. Okay. Next, so we've mixed solution A and B together. Let's look at what that looks like. So, and by the way, let's actually choose some people. Yeah, let's take a beaker and let's use lead nitrate. Now, I'm going to introduce my first solubility rule here, guys. All nitrates are soluble. All of them. Every single one. No clauses, no nothing. All nitrates are soluble, which means you'll never have a solid sign next to a nitrate. How cool is that? Next, we're then going to take another beaker, and what we're going to do is let's add some potassium iodide, yeah, which is also aqueous. Students at this point, how do I know if potassium iodide is going to be soluble? All group 1 salts are soluble, and since potassium is in group 1, they're all soluble, which means it's going to be aqueous. We're now going to mix these things together. Yeah, let's just pour one into the other. Yeah, so we pour one into the other, and what happens is we're going to see this happen. We now get this. The solution now is double the volume and turns bright yellow. It's really cool. Which is this, by the way? It's that. How cool is that? Turns yellow. Do you know that they used to use this solid in paint until kids were eating toys made of it and it poisoned all of them? Oops. So, and what we've formed here, guys, we've formed 2 products. We have formed lead iodide, lead 2 iodide, by the way, which is a solid. And we've formed potassium nitrate. Let's balance the equation, shall we? We're going to need 2 nitrates and therefore 2 potassiums and 2 iodides. So there we go. There's our balanced equation. Now, people often go, how do you know the potassium nitrate's soluble? Because all nitrates are soluble and all group 1 salts are soluble. We learn these rules. These are just lots and lots of rules. We can pick these rules up as we go through the lesson, by the way, if we wanted, but I'm going to do them separately in the next lesson anyway, so don't worry. So I've formed solid lead iodide. Mix them together and stir. Right, now that we've got the solid lead iodide, we now need to get that lead iodide out of the beaker. So what we're now going to do, step number 2, we're going to filter the mixture. Filter the mixture. Right, so what does that look like? Filtering the mixture looks like this. We've got a filter funnel, awesome filter funnel with a filter paper. There we go. Filter paper. We're going to filter it. Let's filter it into a conical flask just because they're cool. We love how cool they are. And what's going to happen is the yellow solid will get stuck in the filter paper. The yellow solid gets stuck in the filter paper. So up here is the solid lead iodide. Lead iodide, solid. And down here, we've got potassium nitrate, aqueous. Okay, so now This is the bit that everyone always forgets. So at this point, everyone goes, like, we're done, but we're not. The reason being is the lead iodide in this step, the lead iodide is, not only is it wet, number one, it is wet. And number two, it's still got trace amounts of potassium nitrate. The reason being is because even though you filtered it through, the solution's still on it. It's a bit like you guys going to the beach, jumping in the seawater, and then coming out and then just drying yourself with a towel and going, oh, but hang on a minute, I'm still covered in salt. When all the water evaporates off you, you still find that you're covered in salt. You have to rinse yourself in clean water. That's why there are showers at the beach, to get rid of the salt that's still on your skin. Even though you're no longer in the sea, you're covered in the water, which has got the salt in it. So what we need to do is step number 3. Step 3 is wash it. Step 3, wash the lead iodide, wash the insoluble salt. Wash the insoluble salt using deionized water. Sorry about the capital U. Deionized water. Now, by the way, if you prefer distilled, that's totally okay. Let's see what that looks like. Annoyingly, this is done in the filter funnel still. So we've still got the filter funnel, and we've still got the filter paper in there with the lead iodide solid trapped in the filter paper. And what we now do is wash it. And by the way, we wash this with a squeezy bottle. I'm just going to draw out one of these bottles for you. Looks a bit like this. And yes, Mr. Duncan's artwork is amazing. Looks a bit like that. There we go. And then this is deionized water. There we go. We're going to wash it. So this here is deionized water or distilled, either one you prefer. I prefer deionized because it tells me a bit more about what it is. It's water that's had all the ions removed. Yeah, deionized water. And we wash it. And the water will literally just dissolve. It'll wash off, yeah, any potassium nitrate residue. I don't like the word residue. Potassium nitrate impurities. It's just washing it off. So this is just, because it's aqueous, it will dissolve in the water and you will wash it off. So now, at this point, we now have lead iodide that we have washed. Now you realize why the soluble salts you can't do this step with. Because if you wash the soluble salts, you're going to lose them all because they'll dissolve in the water and disappear. So you actually wash them in ethanol. So, you know. Step number 4. Now what we do, step number 4. So we've now purified, by the way. That's what we've just done. This is the purification step. So this one is, step 1 is the reaction. This is the reaction. Yeah. This one then is a step 2 is the separation. Separation. And then step 3 is the purification. 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 Step 4, drying. So now what we're going to do is we're going to take out the filter paper. So the step 4 as a bullet point is simply dry salt in drying oven. Now, can I please get you guys to understand that a drying oven is not a normal oven. It only goes up to about 75 degrees Celsius. Yeah, because if you put it into a normal oven, you're going to burn the paper's going to catch fire, and you can't just say dry in an oven. You can't say that. Don't put dry it out in the sun either. You are allowed to say in a warm place. That's okay. They allow that, even though I don't like it. We dry them in a drying oven. This is what we do. Yeah. But you're allowed no other answers. You're not allowed to use a desiccator. Please don't use a desiccator. A desiccator is used for removing like tiny amounts of water. What does this look like as a picture, by the way? So here's what happens. You take out the filter paper with your newly washed solid. you take out the filter paper. Yeah, you take out the filter paper and you flatten it out. And on this will now be your yellow solid. Yeah, and it's wet. Yeah, and you don't want to weigh it yet, because if you weigh it, you're gonna have way too heavy because you've got water that's still there. Yeah, you need to dry this. So you've got that image there now, and you now put this into a little drying oven. You put it into a drying oven at about 50 degrees Celsius. They have little shelves in them. Yeah, you put them on the shelf and you just leave the crystals to dry. Yeah, in a drying oven. And that's it. Drying oven. Nice and easy. That's it. And you now have purified, clean, dry crystals of lead 2 iodide. Yeah, they look rather pretty. Do you want to see what they look like? Lead 2. Oh, by the way, I probably will be able to find one of these just if I continue to scroll down. Just want to show you there. That's what they look like. If we were in school right now, guys, we would be doing this in class, by the way. It's not a complicated issue. And look, you can see how dry they are now that they've come out nice and crispy. It's a weird word, that, isn't it? Crispy. But it is. There's the wet one. Yeah. There's the dry one there, guys. Nice and dry. Yeah. Here's the wet one. There's a wet one in this. There you go. There's the wet one. If you weighed that now, it's going to be way too heavy. Yeah, you're going to think that you've got like over 100% yield because of all the water. So you take that, you put it into a drying oven, and it then comes out looking like that. Which you can then break them off. You can add them to oils to make nice, cool colored oil. Yeah, they're very poisonous, by the way. Although they are insoluble. Yeah, you don't want to eat them. Anything that's lead-based, stay away from. Really toxic. It's nice to mention that, by the way. Just to add this into your notes. All lead compounds are toxic. So what you would do is you would wear gloves. Yeah, wear gloves. Wear gloves in case you got them on your skin and they could be absorbed through your skin. Yeah, so you just wear gloves for it. Obviously, don't eat them. That's a nota bene, by the way. Nota bene. Yeah, there we go. So you'd wear gloves in the handling of lead 2 nitrate. Oh, sorry, lead 2 iodide. Lead 2 nitrate too as well. That's even worse because it's soluble. It's even way worse. Kill you in a blink. Nasty stuff. So what you realize is the insoluble salts are super easy. Mix, filter, wash, dry. We're done. How easy is that? Really, really straightforward. We can even check its purity. It's nice to do this. Step 5, check purity. We can even check the purity using melting point. Check purity by measuring its melting point. Measuring its melting point. I don't know what the melting point is for lead iodide. And the observation, by the way, for a high purity is sharp. This is the observation. Observe, which is a sharp melting point. Sharp melting point means it's pure. Sharp. What that means is it just suddenly melts. Gone. Really sharp. It doesn't slowly melt. Yeah, just all disappears into liquid very quickly. Sharp melting point. I don't know what value it would be either. If it was impure, you'd have a melting point with a range, if you're interested. Yeah, this one's pure. Yeah, impure would be melting point has a range. Has a range. What that means is it would be impure. It's just nice to mention those. Yep, okay. Right, so we've done method number 1. Tick. We can now go back to my learning objectives, and I can now say that we have thoroughly understood insolubles. As we've done the easy one first, right? Let's do the more challenging one. This one's much more challenging. And I need to do this in a very specific context. Okay, so making soluble salts. Soluble salts. Now I'm going to put you into the Edexcel context. They ask it about half the time, and then they give an alternative one that has the same scenario. So, and I'll show you that in a bit. But what we're going to look at is copper oxide which is black. You need to know that, by the way, folks. Copper oxide is a black solid. Yeah, I shouldn't really be coloring this in. I don't really have time to be coloring in, but you know, whatever. There we go. It's a black solid is copper oxide. It's a black solid, and it's insoluble, by the way. Black solid. Right, we're going to react this with sulfuric acid. Sulfuric acid, everyone, of course, knows, is an aqueous. All acids are aqueous. Copper oxide is a solid. Right, guys, pause the video, please, and complete the equation. Don't forget to balance if you need to. So, okay. So pause the video and then have a go at doing it, please. So we've now got, we're going to form copper sulfate, which is blue. And you've got to know that. You have to know that. You're going to form copper sulfate, which is soluble. By the way, it's actually copper 2 sulfate. If you ever have any copper compound, when you write the name, not the formula, yeah, this is copper 2. Yeah, copper 2 sulfate. All coppers are 2+ at GCSE, and we're going to get water. And it's actually already balanced. So what we realize is the salt that we have made is soluble. Yeah. So this is like, soluble. This is a bit more tricky. So what does this now look like? Now, what this now looks like is a whole lot different. Step number 1. Step 1. Mix the copper oxide, copper 2 oxide. It's always copper 2. Copper 2 oxide with the sulfuric acid. With the sulfuric acid. 1 mark. Tick. This is now 6 marks, by the way. Now, here's the thing. We have to make sure that the copper oxide is in excess. Step 2. Keep adding copper oxide. I'm just going to do the formula now at this point. CuO until it is in excess. I'm going to underline the word excess. This literally translates to too much. Yeah. Now, students often go, and a question that's often asked at GCSE, how do you know when the substance is in excess? It will stop disappearing. Yeah. This is observed, this is seen, make it easy for yourselves. This is seen by the black solid no longer dissolving. It stops disappearing. It just sits there at the bottom. No matter what you do, it just sits there. So we add it until it is in excess. Now what this is doing is making sure all acid has been neutralized. Because guys, you're about to heat this, and the problem is neutralized is neutralized. There we go. Is neutralized. All acid has been neutralized because we don't want to start boiling this. Now, what does this now look like? What this now looks like is this. We now have, by the way, I've just mixed the copper 2 oxide with sulfuric acid. I'm so sorry. I've forgotten something, and this is so important. And heat. Can please add that, guys? Oh my God, I nearly missed it. That is so important. If you don't heat this, it won't work. The copper oxide and the sulfuric acid, they have a high activation energy, so you have to provide the heat to make sure the reaction can happen. So you've got to heat it. Can you put that in a bubble, please, saying don't forget it? I nearly did, and I've been doing this a long time. I'd love one. Oh, I'd love a coffee. Coffee would be lovely. Yeah, coffee would be grand. So what does this now look like? This now looks like, so we've realized we're going to add them together. So this original picture, add that into there, and we heat. Yeah. Okay. What does this now look like? It now looks like this. and it's turned blue. The solution's turned blue because copper sulfate is a pale blue. Yet the whole thing turns blue. Observation, a blue solution, but you have a black, leftover black solid. So observation, blue solution with black copper 2 oxide solid in excess. Okay, now all the acid's gone. We have neutralized all of it. Now we can start doing things with it. First thing, step number 3, we need to filter. Step 3, filter out excess copper oxide, copper 2 oxide. What does this look like? It looks like this. Gonna have to get our filter funnel out again. Yeah, filter paper. What this now looks like. Filter, let's go into a conical, I guess, just for fun, because they're fun. Yeah, and the black solid is now trapped on the filter paper. Yeah, there's my excess copper oxide. Yeah, there's my excess copper oxide. Yeah, excess copper oxide. And down here is our beautiful blue solution. And it's now crystal clear. Yeah, there's nothing left but the copper sulfate now dissolved in the water. So we can now go like this. There we go. Sorry about me. I mean to take a bit of time to color stuff in. I just like coloring stuff in. Take the time in your own notes as well. Please do. There we go. So we now have completely crystal clear. By the way, clear does not mean colorless. Yeah, this is crystal clear blue copper sulfate solution. Yeah, so we have now got CuSO4 brackets AQ. Right, now we need to get the salt out the water. So step number 4. Step 4, evaporation. Evaporation. We're going to evaporate. So now what we're going to do is we're going evaporation, heat solution. So 80% of water evaporates. We're not going to evaporate to dryness. No. Nota bene, please. Nota bene. Never evaporate to dryness. The reason being is it will spit at you. Yeah, it will spit. Yeah, that comes up on GCSE questions all the time. Yeah, they love that. It was on the paper my 11s have just sat. It was there. Yeah, you never evaporate to dryness. It will spit at you. And then you'll get boiling hot salt hitting your skin and it'll burn you and leave permanent holes. So what does this now look like? We're going to take our conical flask. And we're going to pour our beautiful blue solution. We're going to pour it into an evaporation basin. Yeah, this is called an evaporating basin on top of a pipe clay triangle. That was the worst pipe clay triangle ever. Always draw the pipe clay triangle first. There we go. How good's that? So this is an evaporating basin. Evap basin. You can't call it a bowl, sorry. This is a pipe clay triangle. Pipe clay triangle. Triangle. It's a small triangle. Nope, it's not. That's triangle. Triangle. Pipe clay triangle. It's like a small triangle. LA triangle. I've lost my mind. Lost it. And we're going to heat. Yeah, if you want to put it on a tripod, you can. But you don't need to draw the Bunsen burner. You just do heat like this. Now, I'm going to actually make the pipe clay triangle just vanish just for a minute, just so it makes it easier to see. What I'll do is I'll do a really silly thing, which is I'll just draw it like this. Yeah, I'm just going to do that just for now, guys. I know that they wouldn't actually care. Come on, Mr. Duncan. Well, that'll do. That'll do. And so what I've now got is my beautiful blue solution in here. Yeah, in my evaporating basin. Right. And we're going to evaporate. And we're going to evaporate 80% of the water. 80% of H2O into the atmosphere. Yeah, the state change there is H2O liquid becoming H2O gas. Yep, and the water will evaporate. Right, now, at the end of the evaporation process, we're going to end up with what looks like, so step 5, zoom, zoom. So step 5, we now have this. And it is crazy dark. Crazy. Look at the color it was before, and look at the color it is now. Yeah, it's become crazy dark. Somebody on the chat, please. Can someone please explain to me why the color has changed? It went from that color to this color. Why? On the chat whenever you're ready. So what we're now going to do is we're now going to use a glass rod, step 5, using a glass rod, using a cold glass rod. You don't actually have to say cold, they allow you not to, but anyway. Using a cold glass rod, test solution for saturation. Saturation. Let me show you what that looks like. So what now happens is they take a glass rod, this cold glass rod, and they touch it onto the surface of, because it's more concentrated, it's not diluted by the water. Well done, Owen, you star. Good man, Owen. Well done. So what now happens is, when you put the glass rod to the surface, you get a really cool effect. Because what happens is, the glass rod has instantaneously gets covered in really cool looking blue crystals. Blue crystals will form crystals, and this is part of the step, by the way. Check for saturation. Crystals will form. Crystals will form on glass rod. On glass rod. Right, that means we're now at more concentrated. Well done, Lauren. Great job. So we've now formed crystals. Step number 6. Step 6, leave to cool down. Step 6, leave mixture to cool. Now, when it cools, crystals will now form. Yeah, what does this look like? Our super concentrated blue solution will now all of a sudden have crystals. I need to show you a picture of that. Copper sulfate crystals. Check out what happens. Images. And it happens in the water. I want to show you this. Yeah, when it cools down, the crystals, I'd love to show you a video. There are some amazing videos of copper sulfate crystals growing. When it cools down, crystals appear in the water. And these are the crystals. They're so pretty. They're so pretty. Yeah, when it cools down, the crystals will form. Yeah, they form beautiful crystals. There we go. It's just cooling down. And the crystal, they've stopped heating it, and they're letting it cool down, and the crystals are slowly forming. Aren't they pretty? So pretty. As I said, if you go to YouTube, you can watch these crystals actually form over time lapse. Really pretty. So crystals will form. And by the way, the crystals do actually have a shape. They're rhombic crystals. Really cool. And then they get stuck to each other. They're really cool things. They're really pretty. I want to make some really big ones at some point. Somebody can come and do that with me at lunchtime one time. So leave the mixture to cool down, so crystals form. So crystals form. Right, now you've got your crystals, you need to filter them out. Step number 7. Step 7, filter out crystals. Filter out crystals. So we've got the crystals have formed in the remaining 20%. It's so pretty, I know. Filter out crystals. Yeah. Honestly, if somebody wants to come and spend a couple of lunchtimes with me, guys, we can grow crystals which are massive and they are so fun to do. It takes a good couple of days, in fact, sometimes even a couple of weeks to make them really big, but you can grow huge crystals. Look at this, they're so pretty. You can even make blue Christmas trees. I'm happy to spend lunchtimes making blue crystals with people. Happy to do so. And by the way, it's blue because it contains the transition metal ion, copper 2+, just so you know. Filter out the crystals. So what that now means is I've now got this image. Yeah, I've got my filter paper, which has now got the beautiful blue crystals on them. Yeah, the crystals are then going to get stuck in the filter paper. You kind of get the point. And then out the bottom just comes the remaining water. Yep, this is just water at the end of it. Copper sulfate, sulfate, yeah, just water. And the crystals are left behind at the top. Now, step 8. Rinse with ethanol. Rinse with alcohol. I'm going to actually give you ethanol. Rinse with ethanol. Step 9. Dry in drying. Leave in warm place to dry. Leave in warm place to dry. And we're done. That's it. And my lesson has 1 minute left, and I'm done. God, guys, that was right to the wire. That. Right, guys, take a screenshot of that if you wish. Yeah, or you can pause the video. But otherwise, guys, that does cover my 2 salt preps, the hard and the easy. We covered purification with rinsing with deionized water. Are they fragile or like they're hard? No, they're hard. The bigger they are, the harder they are, and they're like stone. Yeah, they're very, very hard. They're ionic, very high melting point, very tough. Yeah, Zina, happy to spend a couple of lunchtimes making some with you. Yeah, happy to do so anytime. And that's my favorite part, is just doing stupid practicals at lunchtime with students anytime. Right, guys, I will leave you guys be at that point. That brings me to the end of my lesson. So I'll stop sharing my screen. Stop share. Oh, your browser has lost connection to your camera. That's weird. Right, start cam. That's weird. There we go. Right, guys, I will leave you guys be. Have a look on YouTube for some of the videos of people doing these salt preps. In fact, I will send a couple out on the Google Hangout so you can have a watch of them. But when we get back to school, we will have a go at making all of these. Guys, go and have a lovely rest of your day, and I'll see you all soon. Thanks. See you later, guys. And I'd love to as well, Zina. Fab. See you guys soon. See you tomorrow.